Hello everyone, welcome back to Kcet Karnataka YouTube channel, and today I am back with another session of KPL. Today is match number 16 and I hope you have answered this question paper. The question paper was available in our WhatsApp channel. You can join the WhatsApp channel from the link given in the description and still can download the question paper, try to solve it, and then we can back with the solution. Okay, and if you have not yet joined our WhatsApp channel or subscribed to our YouTube channel, please do so, because here we are doing all the important things related to your PU board as well as your Kcet preparation, right? So without any delay, let me start with today's chapter discussion. We are going to discuss magnetism and matter and current electricity, two chapters. As usual, for last few weeks we are doing two chapters, one important, one medium important. So magnetism and matter is a medium important chapter, whereas current electricity is super important chapters. Okay, we are giving you the question based on some very important questions from these chapters, as well as some of the PYQs are also featuring in this question paper. So if you have solved all the PYQs, if you have understood the concepts, then you can answer these question papers very easily, or you can just download it, keep it for your safekeeping. Later on, when you get time, you can practice from there. Okay, now let's start with the first question. Magnetic needle lying parallel to a magnetic field requires W unit of work to turn it through 60 degrees. So first of all, when it was initially at some angle, so when you turn it by angle 60 degree, the work done is basically given by a formula that you have to remember: 1 mb 1 minus cos theta. What is m? M is the magnetic dipole moment. Okay, m, small m is the magnetic dipole moment, capital B is the magnetic external magnetic field, and theta is by the angle with which you have turned it, right? Initially obviously it was mb. When you turn it by an angle, say theta, then the final is mb cos theta. So whatever the potential energy difference, that is the work done, right? Work done is basically change in the potential energy. So that's how you can calculate this work done. Now it is given that this is W, and the angle is also given, it is cos 60 degrees, right? The angle is also given 60 degrees. Cos 0 is 1, that's why first term is 1. 1 minus, what is cos 60 degrees? Cos 60 degrees is 1 by 2, right? So mb times half, right? Now what is the value of mb? So from there you can calculate mb is equal to 2w. Okay, this is very important. We will use it to calculate the torque. Torque is now given by mb sin theta. It does not depend. Initially sin theta, theta is 0, so initial value of sin theta is 0 obviously, so there is no other term other than this. So mb sin theta is the torque required to keep it in its current position. So now what is the value of mb? Mb we have already calculated, it is 2w, and sine 60 degrees. Okay, so here only you need to apply two formulas to solve this question. So what is sine 60? Sine 60 is root 3 by 2. So 2 cancels, so you get root 3 W is the amount of torque that you need to keep it in its original place. Okay, now next question. A bar magnet is oscillating in the constant magnetic field with the period t. If the mass is quadrupled, then its time period will be. So time period of an oscillating magnet is given by, we have discussed this, 2 pi root over I by mb. Okay, so time period of magnet oscillating in a magnetic field is given by I by mb. Here capital M is the magnetic dipole moment, again B is the external magnetic field, I is not current, I is moment of inertia. I is moment of inertia. So moment of inertia is basically small m r square. Here small m is the mass. Okay, so from here you can say that time period is basically proportional to square root of I, which is in turn proportional to m. So we can say that time period is proportional to square root of mass. Okay, so this is how, because other things are constant, obviously the magnet is constant, magnet is not changing, that means magnetic moment is not changing. You are also keeping the magnetic field as it is, so magnetic field is also not changing. Only thing that you are doing, you are quadrupling the mass. Quadrupling the mass means you are making the mass 4 times. So suppose initially the time period was t and the mass was m, the final time period say t dash and mass is 4m, so here you can say m by 4m, because you have quadrupled the mass. Okay, so from here you can say, okay, mass m cancels, so it will be 1 by root 4, that is 1 by 2. So t dash is basically 2t. Okay, so if you quadruple the mass, the time period will be twice. The time period will be twice. So correct answer is option C. Right? Now, next question. A magnetic field intensity of 3 times 10 to the power of 3 ampere per meter square, meter inverse, produces a magnetic field of 12 pi Tesla in an iron rod. The relative permittivity of the rod will be. Very interesting question. So what we know is that magnetic field is basically given by the permittivity of the medium times the magnetic intensity, magnetic field intensity. Okay, so mu h. So you have to remember this. Now mu, in the other hand, is the permittivity of the medium, that is relative permittivity times the permittivity of free space. Okay, so this is how you can sorry, not permittivity, permeability, my mistake. Permeability, relative permeability times permeability of free space. So you have to find mu r here. Mu naught we know, obviously. So what you have to do, you have to find mu r. So mu r is basically B divided by mu naught h. Right? So mu r equals to B divided by mu naught h. So this is the starting point for our solution, and once you know this, you can do it step by step. Now B is given 12 pi. Okay. Now what is mu naught? Mu naught we know it is 4 pi times 10 to the power of minus 7. What is H? H is a magnetic field intensity, which is given by 3 times 10 to the power of 3. Okay, now what we have to do, we have to cancel them. Pi cancels, 3 4s are 12, 3 1s are 3. So you have answered it. So 10 to the power minus 7 goes up, it becomes plus 7, and plus 3 goes up and becomes minus 3. Okay, so you get 10 to the power of 4. So mu r is 10 to the power of 4. So relative permittivity is 10 to the power of 4. Right? Next question. Above Curie temperature, a paramagnetic substance becomes ferromagnetic, a ferromagnetic substance becomes paramagnetic, a diamagnetic substance becomes paramagnetic, paramagnetic material becomes diamagnetic. So above Curie temperature, what happens to a material? So above Curie temperature, we know that a ferromagnetic substance becomes paramagnetic, right? So it loses its magnetic property. Any magnetic material, when it loses its magnetic properties, it becomes a paramagnetic substance. So you cannot convert it into a permanent magnet unless and until you bring it below the Curie temperature. So a ferromagnetic substance becomes paramagnetic. Very deep question, even though the question is very simple. Very deep understanding question. If you don't know this concept, you will not be able to answer this question. Next, a magnet makes 40 oscillations per minute at a place having magnetic field strength of 1 times 10 to the power of minus 5 Tesla. At another place, it takes 2.5 seconds to complete one oscillation. Okay, the value of magnetic field strength at that place is. So what we have to do? First of all, 40 oscillations in a minute. So 40 oscillations in a minute means you have to first calculate the time period. So time period is basically time taken to complete one oscillation. Time period is time to complete one oscillation. So 40 oscillations in 1 minute, that is 60 seconds. Right? So complete one oscillations, how much time it takes? 60 divided by 40 seconds. So it will be 3 by 2, that is 1.5 seconds. So time period for the first case is 1.5 seconds. Okay, and what else? The magnetic field strength is given by 1 times 10 to the power of minus 5 Tesla. Okay, so let me erase that. Now for the second case, another place, okay, time period is given by T2, which is basically 2.5 seconds, and they ask you what is the magnetic field. Rest of the parameters obviously remains the same. Now we know that T is equal to 2 pi square root of I by MB, or we can say that time period is proportional to 1 by root B. These things you have to understand. You don't need to continue write these long formulas for every while. You have to understand that T is proportional to 1 by square root of B. So T1 by T2 will be square root of, so T, it is inversely proportional, right? So first will be B2, next will be B1. So inversely proportional means the order reverses. So if this is 1 by 2, then it will be 2 by 1. Okay, clear? Now what is T1? T1 is 1.5. What is T2? T2 is 2.5. B2 we don't know, we are trying to find that out, and B1 is 1 times 10 to the power of minus 5. Okay, now let me cancel this decimal goes away. So here you get 1.5 means 3, this is 5, so you get 3 by 5 time is equal to 3 by 5 is equals to B2 by 1 times 10 to the power of minus 5. Right, now what you have to do, you have to square both sides. Squaring both sides we get 9 by 25. 9 by 25 is equals to what? In fractions. So 9 by 25 means if you multiply 4 here as well as here, so what you have to do, you have to multiply 4. Why 4? Because 4 times 25 is 100. Okay, so what is there? 4 9s are 36 divided by 100. So basically you can convert it into decimal. That is your target. That should be your target. And that after squaring we get, right? So we have squared both sides. So now on our right hand side we can write B2 by 10 to the power of minus 5. Right? 1 times is obviously 1 or does not matter. So B2 is basically 0.36 times 10 to the power of minus 5 Tesla. So it is 3.36 times 10 to the power of minus 5 Tesla. Okay, clear? If you have any doubt, don't forget to mention in the comment below. Now, relative permeability of a ferromagnetic substance is 1100. Its magnetic susceptibility is 1100 times 10 to the power of 7, 1099, 1101, 1100 times 10 to the power of minus 7. So relative permittivity is basically, we know that susceptibility is basically relative permittivity minus 1. As simple as that. This is a, I think this is a question from your previous years. Okay, this question came in your previous year, so it will be 1099. So answer is simple as that, 1099. right? Now here I have an announcement to make. If you are studying in PU2 and if you are wondering what to do that for our PU final board exam, then you can join our test series, which we are calling it Success Blueprint test series for PU2 students. Okay, we have recently launched it. I know many of you have aware of it. Now currently we have a special Christmas offer. Okay, you can use my personal code. I am giving you a personal code SAM100. If you use this code while purchasing this product, the link for this is given in the description. If you purchase this product using my code, you will get flat 100 rupees off. Flat 100 rupees off. The cost for the entire course is 599 without this code. Because of this Christmas offer, if you use this 100 SAM100 code, then you will get 100 rupees off. The effective course price will be 499. Okay, and this is only valid till 28th of December. So don't wait, hurry up and purchase as soon as this course, this offer lasts. Otherwise the price will go back to 599 again, right? Now so here the description, the promotion is over. Now let's go back to our class. Relative permittivity of a medium is 0.92. What is the magnetic susceptibility? So again similar question. Now can you identify what type of material it is? Mention that in the comment below. So relative permittivity, again mu r is 0.92. So susceptibility is 0.92 minus 1, that is minus 0.08. So it will be minus 0.08. Okay, so don't so just give you a feel that okay, susceptibility can be negative. Okay, this problem is given, so be careful and tell me what is this material, what type of material it is. You know the type, just answer it in the comment. Next question. If there is no torsion in the suspension thread, then the time period of a suspended magnet executing SHM. So we have used this formula time one more time. So 2 pi square root of I by MB. No, don't fall for any trap. This is the correct formula. You have to remember it and memorize it. Okay. Next question. In normal iron piece, there are no magnetic dipoles. Magnetic dipoles are arranged in a specific direction. Magnetic dipoles are arranged in random direction. None of the above. Magnetic dipoles are arranged in random direction. We know that iron is a ferromagnetic material, right? But if it is a normal iron piece, definitely it does not show any magnetic properties. That means all the magnetic dipole present in the iron, they are randomly oriented so that their average is 0. Okay, in case of random things, we know their average is 0. So here they are randomly oriented. If they are oriented in a specific direction, then it will become a permanent magnet. Okay, in case of a permanent magnet, they are oriented in a specific direction. Okay, but in case of normal magnet, they are oriented at random direction. So you have to be careful to answer this question. Next, the relative permeability is presented by mu r and the susceptibility by chi for magnetic substance. Then for a paramagnetic substance, what is the formula? Okay, for paramagnetic substance, both are greater than 1. Mu r is slightly greater than 1 and chi is greater than 0. Okay, for a diamagnetic substance, I told you that guess what type of material it is. For a diamagnetic, this is for para. For a diamagnetic material, mu r is less than 1 and chi is less than 0. So chi is negative. Okay, but for ferromagnet, mu r is very greater than 1 and obviously chi is also very greater than 1. Okay, so this is the relationship that you have to remember. So for paramagnetic substance, it is greater than 1 as well as it is greater than 0. So this is the answer, both are greater. Okay, now next question. when a material is placed in a magnetic field B, a magnetic moment proportional to B but in a direction opposite to B is induced. So you placed a material in a magnetic field, okay, a small magnetic field inside this material is produced, but that is in the opposite direction. What is the material? Only one type of, so facing a magnetic field opposite direction means it is opposing the magnetic field. Only one substance can do that, that is a diamagnet. So this is a diamagnet. If it is induced in the same direction, okay, then definitely it's a it can be a paramagnet, can be a ferromagnet. If it is strong in the direction of field, then it is a ferromagnet. If it is weak in the direction of field, then it is a paramagnet. But if it is opposite, then definitely it is a diamagnet. Next, among the following properties describing the diamagnetism, identify the property what is wrongly stated. So let's see what are the properties stated about diamagnetism. Diamagnetic material do not have permanent magnetic moment. Yes, correct. Diamagnetic material do not have any permanent dipole moment. Diamagnetism is explained in terms of electromagnetic induction. Maybe not. Let's see what are other options are saying. Diamagnetic materials have a small positive susceptibility. No, diamagnetic materials does not have positive susceptibility. They have positive relative permeability, but not the susceptibility. Susceptibility is negative. Okay, the magnetic moment of individual electrons neutralize each other. Definitely this is correct. So correct answer is option C. Maybe it is correct, maybe it is not. So in case of doubt, you have to read other options and identify if there are any more direct options which you know is possible or you know this is not possible. So from there you can answer, okay, you can guess it. So I didn't know whether this is explained in terms of electromagnetic induction or not. Actually it can. Okay, but if I was not sure, then what I will do, I will read other two options, and once I read other two options, I will be sure, okay, this is the correct answer. Needles N1, N2 and N3 are made of a ferromagnetic, a paramagnetic and a diamagnetic substances respectively. A magnet when brought to close to them will. So what are the needles? First N1. N1 is a ferromagnetic material, right? First is ferromagnetic. So N1 is ferro. Okay, then we have another magnetic needle. I am not drawing a needle, I am just drawing bar N3. 3 bars, okay. This is ferromagnetic, this is paramagnetic, this is diamagnetic. Now we have a magnet, north, south. Okay, so this is a magnet. Obviously magnet has poles. So what will happen? It will attract N1 and N2 strongly but repel N3. Okay, it attract N1 strongly, N2 weakly and repel N3 weakly. So obviously it will definitely attract this strongly, very strongly, super strong. It will attract it very weakly and it will repel it very weakly. Okay, so correct answer is option B. You can check the other option is attract N1 strongly but repel N2 and N3 weakly. No, it does not repel paramagnetic substance. Paramagnetic substances are attracted weakly, attract all of three of them. No, this is also not possible. So this is the correct answer. So as soon as you have find the correct answer, you can mark it. Next question. A paramagnetic substance of susceptibility 3 times 10 to the power of minus 4 is placed in a magnetic field intensity of 4 times 10 to the power of minus 4 ampere per meter. Then intensity of magnetism in ampere per meter is. So what is the substance given? Susceptibility is given 3 times 10 to the power of minus 4. Okay, in a magnetic field intensity of, so H is given 4 times 10 to the power of minus 4. Okay, now they asked you then the intensity of magnetism I. So intensity of magnetism is basically chi H, as simple as that. Okay, so it will be 3 times 10 to the power of minus 4 times 4 times 10 to the power of minus 4 or 12 times 10 to the power of minus 8. So the correct answer is 12 times 10 to the power of minus 8. Okay. Now, the magnetic susceptibility of a material of rod is 499. Permeability of the vacuum is 4 pi times 10 to the power of minus 7 Henry per meter. We know that absolute permittivity of the material of the rod in Henry per meter is. So you have to find the absolute permeability, that is mu. So absolute permeability is mu r times mu naught. Mu naught value is given in this question. Okay, so what is mu r? We have done that, we have found that it is basically 1 plus chi. Right? Now, then what will happen? So chi is given 499. So 1 plus 499. Right? Susceptibility is given 499, so mu r relative permeability is 500. So absolute permeability is simple problems. You have to practice this kind of problems again and again. Mu naught is 4 pi times 10 to the power of minus 7. Okay, so 5 4s are 2000, 500 4s are 2000, 2000 pi times 10 to the power of minus 7. Now you can take these 3 zeros and reduce it here. So 2 pi times 10 to the power of minus 4. So 2 pi times 10 to the power of minus 4. So this is the correct answer. Now let's go on to the next question. Now we are slowly moved on to the current electricity chapter. A copper wire of length 1 meter and uniform cross-sectional area 5 times 10 to the power of minus 7 meter square carries a current of 1 ampere. Assuming that there are 8 times 10 to the power of 28 free electrons per unit volume, obviously meter cube, in copper, how long an electron take to drift from one end to the one end of the wire to the other side? So this is a drift velocity question. Okay, drift means drift velocity. Obviously we know that I current is equal to N E A V D. Okay, this is the equation for drift velocity. So drift velocity is given by I divided by N E A, right? So what is I? I is given here, 1 ampere current is flowing, so that means I is 1. Okay, what is number density? Number density is 8 times 10 to the power of 28. 8 times 10 to the power of 28. Right, so this is the number of electrons per unit volume. Now what is E? E is the charge of an electron. 1 this place is slightly cramped. Let me move on to the next line, that will help. Right, so current I is 1, N is 8 times 10 to the power of 28, and E is the charge of an electron. Charge of an electron means 1.6 times 10 to the power of minus 19. And what is A? Area is given 5 times 10 to the power of minus 7. Okay, now let's do the multiplication. 5 8s are 40. So 40, 5 8s are 40. Then 40 times 1.6. So you can say 4 times 16. That is 64. Okay. So 64 times 10 to the power of 28 plus minus 19 and minus 7. So minus 19 and minus 7 is minus 26. So it will be plus 2. So 10 to the power of 2. 10 to the power of 2 is the drift velocity. So 1 by 64 times 10 to the power of 2 is the drift velocity. Now they have asked you not to find the drift velocity, but they have asked you that how long it will take the electron to drift from one end of the wire to the other end. So there is a wire, suppose this is the wire, and the electron started to drift. Okay, how long it will take for the electron to start from here and reach here. Now what is the length of the wire? Length of the wire is 1 meter. So length is 1 meter and the electron is drifting with the speed, drift speed of this. This is the drift speed, meter per second. So electron is drifting with the speed Vd. So how long it will take to cover this 1 meter length? So the time taken will be obviously distance divided by drift velocity. So distance is 1, drift velocity 1 by 64 times 10 to the power of 2. So it will be go up 64 times 10 to the power of 2, or to match the answer what you have to do, you have to put a point here and make it 10 to the power of 3 seconds. Okay, so 6.4 times 10 to the power of 3 seconds, which is a very long time. Okay, so from this expression you can see that this is a very long time. So electron takes a very long time to reach from one end to the other, but the electric field moves in the speed of light, and that's why whenever you switch it on, the electric field moves and switches on the light. That's why we get instantaneous effect. But the electron, actual electron, which starts at the center, at the position of where you switched it on, that electron takes a very long time to reach actually the bulb. Okay, so that's why this kind of problems are considered very important, because that gives you an idea that electron drifts very slowly. Now a metal rod of length 10 centimeter and rectangular cross section of 1 times half centimeter is connected to a battery across opposite faces. The resistance will be, so the rod length is, rod of the length is 10 centimeter. Okay, and cross section is 1 centimeter times half centimeter. So let me draw this. This is the length. Okay, this is the length. Suppose this is the width. Okay, so this is 10 centimeter. This is 1 centimeter, and there is a half centimeter width in this direction as well. So this is the rod through which the current is trying to pass. Okay, so what are all the values? Let me clear that. So this is 10 centimeter, the length is 10 centimeter, this is 1 centimeter, and this is half centimeter, this distance. Okay, so now let's see what they have said. Maximum, the resistance will be maximum or minimum, that you have to identify. So maximum when the battery is connected across 10 centimeter cross 1 centimeter faces. So if you connect a battery here and a battery here, then what will happen to the resistance? Okay, will it be maximum? First of all, you have to remember that resistance is basically given by R equals to rho L by A. Okay, rho L by A. So if you increase the length to the maximum and if you decrease the A to the minimum, then your resistance will automatically be maximum. Now if you connect the battery like this, obviously you are getting the maximum possible length between the connection. Also the area in this case is the minimum area. All the other areas, that is the front, this area and that area, all are bigger than these two areas. So obviously the resistance will be maximum when you connect the batteries in like this combination. Okay, so this is the correct answer. Let's see once more the other options as well. Same irrespective of the three faces. Obviously this is not same. If it was a cube, say 10 centimeter side cube, then resistance will be same for all sides, because a cube has same distance from all the sides. It will have the same distance when same surface area as well. So definitely for a cube it will be same irrespective of the surface. Okay, maximum when the battery is connected across 1 centimeter times 2 centimeter faces. Sorry, my mistake, obviously that's why I asked you to read all the options. So 10 centimeter into 1 centimeter means 10 centimeter, this is 10 centimeter, this is 1 centimeter. So if you connect the battery across this surface, definitely this is not the perfect one. Okay, this is not the perfect one. This is not, if you connect the battery from this side and the other side, if you connect the battery from this side and this side, then definitely it will not have the highest possible resistance, definitely. So highest possible resistance when it is connected across 1 centimeter times half centimeter, because in this case the area is minimum, that is only half centimeter square, and length is maximum, that is 10 centimeters. So the resistance will be maximum when you connect it like this. Okay, 10 centimeter into half centimeter, again 10 centimeter into half centimeter is like this. So this will also not work, because that is also have the smaller length and bigger surface area. So resistance will be less. Okay, now you can answer the question in the comment below when the resistance will be minimum for this configuration. When the resistance will be minimum, let me know in the comment below. Question number 18. A car has a fresh storage battery of EMF 12 volt and internal resistance 2 times 10 to the power of minus 2 ohm. If the starter motor draws a current of 80 ampere, then the terminal voltage when the starter is on. So we have a battery, some internal resistance, and there is a starter motor which is working on this configuration. So it is drawing a current of 80 ampere. This is 12 volt and this is 2 times 10 to the power of minus 2. Okay, so 80 ampere current is flowing. Now what is the terminal voltage? Terminal voltage means when you connect, say, a voltage here and here. If you connect a voltmeter here, then whatever is the voltmeter, that is called the terminal voltage. Okay, so what will be the terminal voltage? So current 80 ampere is flowing in this configuration, it is again 80 ampere is going back. Okay, so whatever voltage drop is happening across this, say VR, so we have to calculate this VR, and the terminal voltage is basically the potential difference, which generally denote EMF by epsilon minus this VR. Okay, now what is this VR? This VR is nothing but, from Ohm's law, VR is I times small resistance R, right? The internal resistance R. Epsilon is 12 volt, I is 80 ampere, small r is 2 times 10 to the power of minus 2. So 160, so 12 minus 160 into divided by 100. So 160 divided by 100. Why 100? 10 to the power of minus 2 means divided by 100. Right? So 0, 0 cancel. So you will get V is equal to 12 minus 1.6. That is 10.4 volt. So the answer is 10.4 volts. Okay. Now, next question. This is a very interesting question. I solved it once before. Let us solve it once again. Each resistance in the given cubical network has a resistance of 1 ohm and equivalent resistance between A and B is. So to solve this, first of all, we have to consider a current, say 3I is flowing in the circuit. So 3I is coming through here and 3I is leaving here. Okay, and also you have to consider some battery is connected from outside. This is, you have to imagine. Okay, now what else? All the resistances in this cube have same resistances, right? So if you get a equal path, then the current will divide in equal parts. Okay, so for example, in this case, as you can see, suppose the current has 3 paths. One is along this, one is along this, another one is along this. Okay, so current has 3 paths, this, this and this. Now, are these paths equiresistive in the shortest way? So that you have to check if they are in the shortest way, if they are equiresistive. Equiresistive means number of resistance to reach from starting from here to here, if they are same or not. So first of all, let's see this resistance. 1 resistance, 2 resistance, 3 resistance. 3 resistors, again 1 resistance, 2 resistance, 3 resistance. So this is a equiresistive path. Similarly here also 1 resistance, 2 resistance, 3 resistance. It can go from any direction. The minimum path is always 3 resistances. Okay, for all the components 3 resistances are the equal path. That means current will be divided in here in equal amount. Okay, current will be divided in equal amount. So what is that equal amount? So this will be I, this will also be I, and this one will also be I. Okay, so you should remember this is a trick, that if the circuit is equiresistive and all the resistances are same, the current divides in equal amount. That is a very short trick that you have to remember. Okay, because the path is same, the current will be divided into same part. That's why, because 3 currents are there, I have chosen the initial current to be 3I. Right, now once it reaches this current, suppose reaches here, okay, now it has 2 paths. One is along this path, another one is along this path. So now here no other paths are possible, right? So here this current I will split up. How it will split up? Like I by 2 here and I by 2 here. Okay, and now when it reaches here, now you might say, okay, what will happen at this point? Now at this point, one more current, similarly this current I passing from this resistor, it will be divided into I by 2 here. So this I by 2 will meet, and another I will go to this point, right? Similarly here also another I will come from this side, another I will come from this side. That is the beauty of this kind of circuit, symmetry. Okay, so if the circuit is symmetrical, you can say, okay, I currents are exiting and I currents are entering. Okay, so now our part is done. Now what we have to do, we have to take one loop and calculate what could be the possible resistance, right? So we will apply Kirchhoff's voltage law, Kirchhoff's loop rule, whatever you say. Okay, KVL, Kirchhoff's voltage law, Kirchhoff's loop rule. If you are using loop rule, that is if you are saying loop rule, that is also fine. But in most books, most where I have seen, they have said voltage law except NCERT. In NCERT, they have mentioned it as loop rule. Okay, but all other throughout my life, we used to study this as Kirchhoff's voltage law. Okay, no matter what you have learned, the same thing. It is just the name is different. Now, if you consider, say, this path. Okay, this path. Okay, if you consider this loop, okay, now each of the resistances, for now let's assume that each of the resistances are small r. Okay, small r, all of them have same value, 1 ohm. Okay, so for now I am assuming they are all small r is equal to 1 ohm given in the question. Okay, now what do you have to do? So if you consider this path, what is the voltage drop across this resistance? I times R. Plus, now if you consider this resistance, it is now I by 2 times R. Plus, now you consider this resistance, here I times R again. Now this should be equals to the external voltage source. Say external voltage source is V, then it will be V, that is Kirchhoff's voltage law. If you take the loop, okay, if there is a voltage source, if you add all the voltage drops across the resistances, then definitely that will give you the external voltage source. Right, now add them. So IR plus IR is 2IR plus I by 2 R equals to V. Now add them, 5 IR by 2 equals to V. Okay, so this is the part where you have to put the value of small r. Small r is 1 ohm, as I said. So 5I by 2 equals to V. Okay, so this is the fact. So from here you can say, okay, V by I equals to 5 by 2. Okay, now remember that. Now if we replace this entire jumbled up circuit with a single resistance, that we call equivalent resistance. Okay, if we replace this all the jumbled up thing with a single resistance, such that now we have only one resistance and the battery as it was fixed in the previous case, then we assumed what is the current through this part. We assume the current through this is 3I, and current that is coming out is also 3I, right? So in this case the current that will go in will also be 3I. That's why it is called equivalent resistance, and the come out that will also be 3I. Right, now if you apply KVL in this single loop only, okay, then you will get, or Ohm's law also, whatever you want to apply, R times 3I, that is current times resistance, is equals to the voltage. Okay, or V by I, we are trying to find this resistance R, right? So what is that? So resistance R is basically equals to V by 3I. So don't make a mistake, because you have assumed 3I, the final answer should also be 3I. So R is basically V by 3I, or 1/3 of V by I. We have already calculated, V by I is 5 by 2, so 5 by 2, so that is 5 by 6 ohm. So the equivalent resistance in this case is 5 by 6 ohm. Okay, correct answer is option C. Now if you remember that no matter what type of circuit is given to you, you can answer it will be 5 by 6 ohms. If they are, suppose in the same problem is given, but instead of 1 ohm they have given you 2 ohm, all the suppose, okay. So if they give you all the resistances to be 2 ohm, then how to solve this question? Similar question. So you know that the factor is 5 by 6. So in that case you have to do 5 by 6 times 2 ohm. Okay, so it will be 5 by 3 ohm. If they say, okay, now we want to give all the resistances 6 ohms. If all the resistance is 6 ohms, then it will be 5 by 6 times 6. So whatever resistance they will give, you have to multiply it with the factor of 5 by 6. That is the shortcut formula. If you we have done the derivation for that. If you remember it, it is very good for you, okay, because you can solve similar questions that might come in your upcoming Kcet exam easily, like this, because they don't want the process. If the same question comes in your PU board, for some reason they want to make a difficult question paper for your PU board, and this question comes in your PU board exam, then this method of multiplying with 5 by 6 will not work. In that case you have to do this entire mathematics that I have done. Okay, but if the question comes in a Kcet exam, does not matter how you are solving, as long as you are solving it correctly, that is absolutely fine. Okay, now next question. IV characteristics of a copper wire of length L and area of cross section A is shown in the figure. The slope of the curve becomes. Now they have asked you about the slope of this curve. Slope of this curve means if this angle is theta, then slope is basically m is equal to tan theta. And I versus V graph, if this is I versus V graph, okay, we know that V equals to IR. Okay, so resistance is basically V by I, right? Now you have plotted the graph. This is your y-axis, this is your x-axis, right? Now what is slope? Slope is basically delta y by delta x. These are the important concepts. So in this case it is delta I by delta V. Or in this case, because it is a straight line, you can simply say okay, this is not delta V by delta I, this is I by V only. Okay, so I by V is what? I by V is 1 by resistance, right? I by V is 1 by resistance. So slope is basically in this case is not resistance but 1 by resistance. Be careful. If the axes were changed, if I was plotted along this axis and V was along this axis, then that case slope will be equals to resistance. But in this case V is plotted along x-axis, I is along y-axis, so slope is basically 1 by r. Now let's see what is the option. Less if the area of the wire increased. Okay, slope of the graph will be less. So slope of the graph is basically dependent on the 1 by r resistance. Now resistance is basically rho L by A. Okay, so slope will be equals to A by rho L because it is inverse, right? So M is obviously 1 by R, so you have to just reverse it. So less if area of wire increases. So if the area of wire increases, then slope will also increase, right? So directly proportional to area. Slope is directly proportional to area. So if area increases, slope will increase. Less if length of the wire increased. So if the length of the wire is increased, then slope will decrease. That is, yes, it is correct statement. Okay, you can check the others two option also, but we have found our correct answer. Okay, more if experiment is performed at higher temperature. So as the temperature is increased, then rho will increase. Increasing rho means M will decrease, so definitely that is not true. Okay, more if a wire of steel of the same dimension is used. Okay, copper again in case of steel, this will be a different value, it will be more value. So in that case again M will be decreased. Okay, so less if the length of the wire is increased. That is the correct answer. Okay, now next question. Though the electron drift velocity is very small, that we have already seen in one of our problem, electron charge is very small, a conductor can carry an appreciably large current because, so drift velocity is small. Okay, so what is the current? Current is basically NEAVD. Okay, so first of all you have to understand that VD is very small value. Area, so if you take a normal copper wire from your household, you will see the area of that copper wire is very small, right? But still it can carry a large amount of charge, large amount of current, which is in terms of large amount of charge as well. Now electron, obviously this is also small, 1.6 times 10 to the power 19. So why it can carry that much amount of current? Because of the high amount of N, that is number density. Number density we have seen in that problem we have solved, it is on that order of 10 to the power of 8 per meter square, electrons per meter square, right? So that's why because of the high number density it can carry that amount of current, right? So electron number density depends on the temperature. Electron number density is very large, relaxation time is small, drift velocity of electron is very large. Obviously these two are contradicting. So electron number density is very large. Okay, that is why because of high amount number of N, your I can be a very high value, even though all the other values in this expression is small. Okay, because of only one factor, that is high number density. Next question. Masses of 3 wires of copper are in the ratio 1:3:5 and their lengths are in the ratio 5:3:1. The ratio of their electrical resistances are. So first mass is given. Okay, mass is given M1. Say I will assume the constant of proportionality is 1 for simplicity, because we are solving for Kcet. So mathematical exact accuracy is not required, only approach should be correct. So mass I am assuming first wire say 1 kg. You can add one constant k, but that is not required in this case. So mass for the second wire will be 3 kg. Okay, mass for the third wire will be 5 kg. Similarly, the length for the first wire is 5 meters. Okay, length 2 is 3 meters and length 3 is 1 meter. Okay, so this we have assumed. Now why the mass is important? Okay, mass of an object is basically the density times area. Okay, so density times volume. Mass is density times volume. Now what is the volume of an object? Volume of an object is, we have solved this in our class as well. Volume is length into area. Volume is length into area. Okay, and the formula that we know for resistance is basically rho L by A. L is given, but what about the area? Area is not given, so we have to calculate the area. To calculate the area, we have to use this. So area is equals to M by density. Now I am doing one more cheating. I am taking this density to be 1 as well. Density is constant. So any constant while solving objectives, we can take this to be 1. Okay, that is the cheating I am doing. So 1, assuming density is 1, so area is basically M by L. Right? So area is M by L. Now let's see what will happen for this formula now. Let's put this value in this equation. So R is equals to rho L by M by L, or it will be rho L square by M. So what is the ratio of resistances? R1 is to R2 is to R3 is basically, rho is constant for all of them. So L1 square by M1 is to L2 square by M2 is to L3 square by M3. Okay, now let's put the values. L1 is 5. 5 square is 25 divided by M1. M1 is only 1. So 1 is 2. What is L2? L2 is 3. So L2 square is 9. What is M2? M2 is 3. So it will be simply 3 is 2. What is L3? L3 is 1. So 1 square is 1. What is M3? M3 is 5. So you get 25 is to 3 is to 1 by 5. Now that is not the way to write a equation. So what you have to do, you have to multiply 5 to all the terms. So 5 times 25 is 125 is 2. 3 times 5 is 15. Okay, 5 times 1 by 5 is 1. So it will be 1. This is the answer. 125 is to 15 is to 1. Okay, this is a slightly complicated question, but if you make it easy like this, then definitely you can answer such questions, such difficult questions easily. Obviously not simple question. You have to do the mathematics. It will take some 2 to 3 minutes to solve, but if you have the idea how to solve it, then you can solve. Suddenly they have given you mass. Don't confuse the mass with the area. Okay, many students, if you put it as area, then your problem is completely gone. You will find a wrong answer and you will get a 0 marks. Okay, there is no negative marking for Kcet. That is a good thing. So, but you will still not be able to solve it properly. Now, next question 23. In the given circuit, the current through 2 ohm resistor. So, current through this 2 ohm resistor. You have to find the current through this 2 ohm resistor. Now this is a very tricky question. Why this is a tricky question? So current starts from here, okay, and if you see there is a short here. Short means it is direct path. So current, what is the minimum resistive path for the current to flow? So minimum resistive path for the current to flow, it will go here, it will come through this, it will come through this, and it will pass through here and it will come here. Okay, it will not pass through any other resistors. You can simply ignore all of these resistors because they are not at all contributing to anything. So you can simply say, okay, tata, goodbye, you are not helping me, so I can erase you from this. Okay, in fact, these are also not contributing, these are also not contributing, they are all garbage. So the circuit is basically this. Why? Because they are all have resistances, but this path does not have any resistance. So even though the circuit looks complicated, you might be wondering, oh, this is a very long question, I have to take, okay, this is series, this is parallel, etc., etc. You don't have to worry too much about it because they have given you a shortcut. So this is a trick question, straight cut trick question, no mathematical trick, no physics trick, it is a visual trick. Visual trick is that you have to understand, okay, because there is a shortcut happening, then there will be no current flowing through any other resistors. Okay, now, so 1 ohm here, 2 ohm here. Now as you can see, if you start here, you can construct them without lifting your pen. That means it is a series combination. So in case of series combination, what you have to do, equivalent resistance is given by 1 plus 2, that is 3 ohm. Okay, so equivalent resistance is 3 ohm. The battery voltage is 1.2 volt. So what is the current? Current is V by R, that is 1.2 by 3, that is 0.4 ampere. Now the 0.4 ampere is the current in the entire circuit. The same current will pass through both the resistors, 1 ohm as well as 2 ohm. Okay, same amount of current will pass. So here the current is basically 0.4 ampere. Okay, now next question, Kirchhoff's junction rule is a reflection of. Kirchhoff's junction rule is what? Junction rule is when the current entering multiple points and they are exiting through multiple channels, then we know that whatever current is in, the same current is out, total current, right? So sum of current in equals to sum of current out, right? So sum of current in is equal to sum of current out. That is what is known as Kirchhoff's junction rule. So Kirchhoff's junction rule, that means it is basically conservation of charges. It represents conservation of charges. Kirchhoff's loop rule, on the other hand, is a conservation of energy. Okay, I discussed this many times if you have missed it. So Kirchhoff's junction rule is conservation of charges, Kirchhoff's loop rule is conservation of energy. Next question, the variation of terminal potential difference with current flowing through a cell is as shown, the EMF and the internal resistance of the cell. So this is an easy question. So as you can see that this is a variation of voltage, terminal voltage and current. Okay, now when this is happening when the current in the circuit is 0. If the current in the circuit is 0, that means whatever potential you are measuring, that is actually the EMF of the cell. So EMF of the cell is 3 volt when current is 0. Now when is the cell potential is 0, x-axis means y is 0. So here when the current is maximum, the cell potential is 0. That means what you have done, you have taken the cell and you have shortened it. You have directly shortened it. So whatever voltage is here, the same voltage is dropped across this resistor so that the terminal voltage is 0. Right? So what is the current in this case? Current in this case is given by 6 ampere. So 6 ampere current is flowing. So if this resistance is say R, then 6R is equal to the terminal voltage, that is 3 volt. We have already seen the terminal voltage is 3 volt. So R equals to 3 divided by 6, that is 0.5 ohm. So 3 volt and 0.5 ohm is the answer. Okay, 3 volt and 0.5 ohm is the answer. Next question, Ohm's law is applicable to a diode, a transistor, an electrolyte, a conductor. Ohm's law is applicable to conductor. It does not apply, is not applicable to diode, transistor or electrolyte. Next question, the effective resistance between P and Q for the following network. So effective resistance between P and Q for the following network. This is also interesting question. How to solve it? So first of all, you have to realize that these two resistances are connected in series. You can draw these two resistors without lifting your pen. That means and in the direction, same direction, right? If you suppose you want to draw 6 ohm also, then it will have to go to the other direction, right? So from P to Q, if you are trying to reach from P to Q, you can see that these two resistances are can be drawn without lifting your pen. That means they are connected in series and there is no other obstacles, right? So this can be written, this can be drawn as right. So these are just to confuse you. So these 3 ohms and 3 ohms are connected in series. So the equivalent resistance for this combination is basically 3 plus 3, that is a 6 ohm. 6 ohm. This is also 6 ohm. Now when two equal and opposite two equal resistances are connected in parallel, what is the equivalent resistance? When two resistors of equal length are connected in parallel, their equivalent resistance is half of any one of them. So both are 6, so half will be 3 ohm. Okay, now what is this? This is 4 ohm and this is 5 ohm. Okay, this is P, this is Q. Now if you see, they are connected in series. Now they are connected in series. So 4 plus 3 is 7, 7 plus 5 is 12. So the equivalent resistance in this case is 12 ohm, right? 4 plus 3 plus 5, that is 12. Okay, 12 ohm is the answer. Next question, the potential difference between point P and Q in the electric circuit shown is. So 15 ampere current is flowing through this circuit and they have asked you what is the potential drop between P and Q. Now if you might see, this is very similar to a Wheatstone bridge, but actually it is not a Wheatstone bridge because there is a resistance in between and not a galvanometer. Also the connection is not like this. The connection was like this, then that may have been a Wheatstone bridge combination, right? Now here what we have a current 15 ampere passing through this. If you can calculate the equivalent resistance of this circuit, so if you can find only the equivalent resistance of the circuit, 15 ampere current is passing through it, then whatever the equivalent resistance, that times current gives you the potential drop. So how to do that? So first we will consider this arm. What is this? These two resistances are connected in series, right? 3 and 4 are connected in series. Similarly in this side also 6 and 8 are connected in series. So the equivalent resistance, to calculate the equivalent resistance, we have one resistance like this, and combining 6 and 8 is 14. 14 is like this, and we have 3 plus 4, 7 in this side. 7, 2 and 14, and they are connected. Now these three resistances are connected in parallel. So what is the equivalent resistance? So equivalent resistance, say Req, obviously we already assumed that. So 1 by Req equals to 1 by 7 plus 1 by 2 plus 1 by 14. LCM is 14. So 14, 7 2s are 14 plus 7 2s are 14 plus 14 1s are 14. So it will be 7 to the 9, 9 plus 1, 10. 10 by 14. Now this is 1 by Req. So Req is 14 divided by 10, that is 1.4. Okay. Now what we have to do, as I said, to calculate the voltage drop is old friend Ohm's law. V is equal to IR. So I is 15 and resistance is 1.4. Okay, or let me keep it as 15 by 10 only, that will help. Okay, now what I will do approximation as usual. You can do the mathematics, you can calculate exact value, okay, but I like to do approximation. Approximation is my best friend. So what is the answer for 15 into 15? 15 into 15, we know that is 225, right? 15 into 15 is 225. Here we have 15 into 14. Okay, so you can minus another 15 from this to calculate 15 into 14, right? 15 into 14 is basically, you can do the multiplication in whatever way you want, but I find this method is useful. So 15 into 14 is basically 15 minus, right? That is the thing, right? So 210. So 15 into 14 is 210. So it will be 210 divided by 10, or it is 21 volt. So 21 volt is the answer. Or in this case, you can even do the approximation is that 15 into 15 is 225. So you can say this is almost 225 divided by 10. That is almost 22.5, and you can check which one is the closest. 21 is the closest. So definitely this is the answer. That is also a process to solve this question. Okay. So always try to use your known resources, your known values, known answers. That will save a lot of time for you. Next question, the resultant resistance value of n resistances each of R ohms when connected in parallel is X, where when these n resistances are connected in series, the resultant value is. So each resistances, say n resistances, all of them are connected in parallel. Okay, so there are n resistances, they are connected in parallel. All of them have value R. What is the equivalent resistance? Equivalent resistance is basically given by X equals to R by N. As simple as that. When you are connected in parallel, the equivalent resistance is R by N. When you connect all of them in series, that is easy to answer. Equivalent resistance in series, say R equivalent is equal to N times R. Okay, but we have to calculate this in terms of X. So what is the value of R? R we don't know, R is not given. So we will calculate R equals to Nx. R equals to Nx. Now put this value here. So R equivalent is N times Nx, that is N square X. Okay, so answer is N square X. Simple question, okay, but you have to know this knowledge. If you have this knowledge, you can solve it less than 1 minute. Now another question, find the equivalent resistance between the terminals A and B in the circuit shown. So you are trying to find the equivalent resistance between A and B. Another tricky question, again here as you can see, if you start from here, okay, you cannot reach to C. There is no path here. But if you start here, you have to go from this side. Okay, or you can go from this side. Right? So there are two paths available. So these two resistances are basically useless. They are not contributing anything in this circuit. So what we have to do, we can ignore these two resistances and we can start calculating. First step is to calculate the equivalent resistances of these three resistors. Okay, these three resistors we will do it first. So 2, 2, 2, they are all connected in series, right? So I hope you are familiar with how to know they are connected in series or parallel or not, or else you have to solve a lot more problems to identify that okay, this is series, this is parallel. So these resistances are connected in series because we have ignored all of these two resistances, so you are not considering them. 2 plus 2 plus 2, that is 6 ohm, right? So this is A. There is a 3 ohm here, there is a 3 ohm here, there is a 3 ohm here. So 3, 3, 3, and here we have a 6 ohm. Okay, now what we have to do, we have to find this parallel combination. Okay, what is the parallel combination of this? Two resistances connected in parallel, we can easily find the equivalent resistance, that is R1 R2 by R1 plus R2. right? I hope you remember this formula. So here it is 3 into 6 divided by 3 plus 6. Okay, so it is 18 divided by 9, that is 2 ohm. So the equivalent resistance for this combination is 2 ohm. So what we have to do, we have to just remove them and add a new resistor of 2 ohm. Now what is the total resistance? 3 plus 3 plus 2. All of them are series. So 3, 3, 6, 6 plus 2 is 8. So 8 ohm is the equivalent resistance. Okay, so I hope you enjoyed today's KPL session, and if you have not yet subscribed to our channel, don't forget to subscribe to our channel. I will be back with more videos in our channel. Other teachers are also doing a lot of things in our channel currently. If you are aware of that, I will be back as soon as possible. Till then, bye. See you in our next video.